And then next, our next session is water conservation and water quality. We'll actually have someone else here from LCRA, Brett Bryant, and he's going to talk about some really great water conservation rebates that LCRA has that the city doesn't have, so we can save more water if we need to. Yeah, I mean, I like being on time. I don't think Lauren minds starting a little bit early today. So our next speaker is Lauren Stanley, and she's a practicing architect with Stanley Studio, Architecture and Metalwork. And she is very involved with the green roof movement. She was one of the co-founders of a green roof networking nonprofit, and she was also on the green roof advisory group as a stakeholder for the city of Austin. So she's very invested in our community. So please help me welcome Lauren Stanley.
Good morning, everyone. It's going to take me a little bit of time to... propagating green roofs. So, yeah, I'm an architect, always very interested in the wider picture, the wider context of where our buildings sit and how they can perform, and environmental issues in general. So that green roofs is sort of a natural draw for me. And I was asked to talk a little bit about green roofs more from the practical side instead of sort of a 101 basic kind of... I don't know how many people here... are familiar with green roofs or have even had experience with doing anything with green roofs. Can I have a show of hands and see? Quite a number. That's great. So, yeah, I'm just going to kind of focus a little bit more on the practical side. But it couldn't. As I was doing this, I realized that putting this whole thing together and some ideas, I realized that the practical side was very much intrinsically related to why we do them and what they are. So I'm going to go ahead and give a little bit of, I can't help myself. I have to talk a little bit about why we do these. Really, the thing that is most important to me, that touches me the most, is this idea of bringing nature into the cities and trying to green them as much as possible in really inventive ways. And a green roof technology is quite unique in that it's not, there's a lot going on. There's many components. So you mitigate the urban heat. I think that there's a way that we can look at having them actually do many things like landscapes at once. All these things that you're seeing here. It tempers, it filters, it sequesters, it metabolizes, it enhances. It becomes a rich layer on top of a building that has customarily is completely not thought to do any of that. It's the opposite. Usually a roof is meant to just kind of get stuff off it, water, and shield people, building envelope. So the larger urban context, green roofs are a unique multifunctioning tool in the Green Infrastructure LID toolbox, which enables buildings to directly engage with their environment. And then specifically to buildings, it's an integrated architectural biodynamic system that enhances performance in all kinds of ways. There's a lot of different ways you can think of performance. And so like I was saying before, why you build them translates directly into what you build and how. It's a living sponge. It's just doing all those things. It's filtering, it's sequestering, it's doing all those things that it's creating a little environment, and you obviously have to protect from the architectural, the underside. So that's what makes it kind of a little bit more of a complex creature. So what is a green roof? Just really quickly, these why and what portions of the talk are sort of meant to kind of go through relatively quickly. They call them green arts and gray arts, and there's a kind of a distinction there that you need to, people need to be aware of. So all these things that are listed here are things I'll talk about. And just as an aside here, the image that you're seeing of the building, top and bottom, is from Stuttgart. And Germany is very advanced in their kind of mandate to have green. I think Stuttgart is one of the cities that mandates green roofs on all public buildings. So they're doing a lot there. Okay, because I was sort of led to know that handouts would be available and that it would be, some people can't make this, I thought, okay, I'm just going to like spill it all out on paper here. So I'm going to be doing a lot, just taking directly off my presentation here. It's kind of a little bit text heavy here. So integrated system, but distinct disciplines and scopes of work. You need to get the roof right. It needs to be well detailed, well draining, and leak proof, and that's can't be underscored enough. You really need to get that right, because as soon as you have a leaky roof, and leaky roofs happen with or without green roofs on them, it casts a pall on a green roof in general, which isn't quite fair. So it's just much harder to take off all that stuff that a green roof is in order to get to the underneath to fix it than it would be for an ordinary roof. So yeah, the waterproofing layer is typically a TPO, PVC, a membrane roof, various kinds. The Wildflower Center, the Lady Bird Johnson Wildflower Center likes to use an elastomeric, a seamless. I'll talk about that a little bit more later. And then what are some of the other gray elements that are needed because of the green ones? You've got an edging system, an edging barrier, a retainer, pavers, borders, an irrigation system, monitoring equipment. So there's a lot of other stuff up there. Not a lot, some. It depends, that you have to accommodate for. And then the green components generally start with the drainage layer going up. So you've got the membrane, it's solid, that's on top of a dense deck, kind of a board that the membrane adheres to, and then insulation. But then pretty much drainage layer up, you're talking about the green roof. And this last bullet point here, consider the gap. They're finding now that here, and particularly in this climate, with extensive systems, which are real shallow, roots are not, their feet are not used to having a layer of air underneath that can desiccate more and get a little hot, or a different temperature than it would be just a geothermal kind of environment. So that's something to consider. They're really being taxed up there, particularly if it's a extensive system that doesn't have a lot of depth, as opposed to an intensive system that has more depth to kind of buffer that temperature change more. Why is a green roof desired specifically? What are its purposes? What makes an owner want to do a green roof? And that really, it might sound, there's a lot of sort of things to consider there. And a green roof is sort of a green roof at the end of the day, but you might want to might want to have a more vigorous kind of a water environment up there, a sort of richer environment which takes more water and takes more inputs. So is there an emphasis on low inputs? You really don't want to put much up there or in over time as well as initially for cost reasons? Or do you want to have more of a, you want to have a little bit more performance? So those are kind of, you sort of dial them one way or the other. Is the emphasis on common good, the sort of urban, wider picture, urban heat island mitigation? Or is it more private benefit, insulation, thermal insulation, sound insulation, amenity, private kind of aspects? What kind and how much access? Are you going to use it as an amenity? Is it going to be a deck? Do you want to go up there? Do you only go up there for maintenance? Two approaches, less is more and more is more. Both are valid options. Again, the low input scenario, there's less resource use, less cost, less performance. And the high input scenario is more of all that stuff, and you get more performance. So as I'll go into later, it doesn't necessarily mean, I really don't think that the high input scenario is bad because of more resource use, including water. There's a lot of sort of other considerations that come into play there. What's your water source is the big one. Can you do it so that you're not drawing off the city supply? So you establish goals before moving to design. By the way, if anyone has questions along the way, just break in. Feel free to do that instead of waiting to the end. So what are you working with? What's the host kind of body, the architecture? Is it a new building? Is it a retrofit? Each has its own challenges. Are there architectural drawings you can find if it's an old building? the structural engineer has to jump right in pretty quickly if it's, well, in both cases, but especially retrofit. So often those structural considerations come at the foundation level. In other words, the constraint, the limitations are really sort of found sometimes in the actual foundation, what the foundation can do, rather than the actual roof span. It's a little harder sometimes to get that right. The parapet roof or the shed roof both require adequate drainage at the edge. You need to think about scuppers and how you're getting water off. What's your walk surface? Going to be across it, around it? How do you protect the membrane? The depth of the green roof system determines the plant palette options. So that, again, is going to be sort of more your extensive versus intensive system. The deeper the media, generally, the taller the species and the more variety of species. You can get trees and shrubs up there. I don't know if you all are aware, but City Hall is also has green roofs of various kinds here, all intensive, I believe. I don't think there are any extensive ones, so you can see a lot of stuff growing out there. Wonderful space. Yes?
What is the deepest depth that you've seen?
I haven't personally seen a lot. We've probably walked on a lot of intensive green roofs and not been aware of them. Sometimes they'll be sort of in, like Chicago, Millennium Park. I don't know, 6 feet, 4 feet, if anybody knows. I don't really know, but somewhere around there. I mean, at a certain point, it gets just ridiculously heavy, so. But 4 feet, 3 feet. 3 feet is sort of your typical kind of, what you hear a lot about intensive roofs. So the shallow extensive roof systems has a pretty porous structured media, and that's intentional to try to get it to drain well, and so that it tends to dry out quickly. It doesn't hold on to stuff a long time. Irrigation is generally needed for establishment, which is generally considered to be about a year. But if you got an irrigation system up there, you're not going to take it off probably after a year. It's going to be up there, so it's another system you can draw on, use. Relying principally on collected rainwater or HVAC condensate takes green roof watering out of the potable municipal demand. So that's what I always try to go after. But having said that, if you're very xeriscapic and with your plant choice and you consider the roof as another landscape and you water your landscape, it's another landscape that you water, and there's plenty of, I would say most landscape watering done right now is from the city supply, for better or worse. Okay, upfront costs and life cycle costs, incentives. They're not a low budget choice. They're not going to be something that you do if you're really in a pinch on a building budget. It's a bell and whistle kind of thing. So it's not easy to calculate cumulative payback. They're worth it in a lot of ways, but you might say, okay, well, we can kind of drum up the capital cost and cover that because there's a life cycle cost, there's a payback. What is that? And that's hard to get to. It's not, the metrics are kind of difficult. This is a living system, so it's real hard to get that under wraps. So a value arises from a matrix of interconnected benefits. Variables fluctuate since it's a living system. It makes metrics hard. Some attributes are quantifiable. Stormwater retention, you can measure what a 1-inch rainstorm will, if it captures that and holds that, where that break point is, where it starts to shed and not sequester anymore. And others do not lend themselves to consistent data. I think there have been a lot of studies. I'm not up on them because I'm not a study data sort of person. But there have been a lot of people trying to get their heads around thermal insulation. There's definitely insulation that happens. However, if you have a thicker roof that gets wet and it's cold, it can actually kind of wick heat away from the building. So it's kind of hard to establish. I think what they decided is that on an annual basis, you can kind of take an average where most of the time that green roof layer is going to be insulating your building, and in a good way, keeping the internal temperature where you want it. And there's a certain portion of the year where that it's going to work counter to the goals of the interior conditioned space, and average that out. Real estate value of green roofs. Views from above, they are definitely getting higher rents, and prices for any rooms that kind of look down over a green roof in different examples around the world. It has to avoid becoming a liability. So you want to make sure that it's just done right, detailed right, designed for longevity and flexibility. Part of that is there an envisioned feature where you're changing that rooftop? So that flexibility, maybe you want to change the plantings, maybe if 50% of it's planted up there and the other 50 is an amenity, a deck or something. Is there a future scenario that is envisioned where you might want to mix that up a little bit and change that? So thinking about those things. The incentives in Austin at this moment are not explicitly financial. There are, with the GRAG, the Green Roof Advisory Group that I worked on, we started with looking at what some of those, what would exist right now on the books in terms of like what would incentivize you non-financially to build green roofs, and went from there. At the end of that period of time, this was 2009 to 2011 or so, that GRAG period, one of the last things that was developed was getting green roofs in as a single option, a standalone option for a density bonus program. In certain districts, I think the downtown and the Highland Mall area. And then it's part of an option to discharge, this is more recent, to discharge stored rainwater by using that stored rainwater instead of just discharging it so that it's empty. I think it's 48-hour period. You irrigate the green roof, so it's sort of a loop. The green roof is a part in that system. And then there's just open space credits, green building rating points. So not a whole lot has been developed yet compared to other cities. Okay, so the how, what I wanted to focus a little bit more on, and this is where pepper me with questions if you'd like to. So you have, you got to realize that you need a team that's pretty wide. There are a lot of different players. Since this green arts, gray arts thing, it's all coming down to one, very distinct, specific layer, as opposed to an entire building site. It's a very distilled kind of a place that you're doing green roof on, an area. So you can use a proprietary system, American Hydrotech, where they have a proprietary growing media, and they've got plant specialists and botanists and horticulturalists, and they'll tell you, well, in your area, in your zone, you're going to want blah, blah, blah. I don't know how much, I'm sure you get a little bit of, I haven't worked with them, a little bit of say in your plant choice, but they have specialists that they try to cover, they give you a package or a product that's, you don't have to think too much about it if you're not as educated about what green roofs are, and you pay for that. Monolithic versus modular, all these different things I will go into. So your team may include, does include an owner, may include an architect, a landscape architect, or a consultant, designer. Definitely structural engineer. Green roof professional is a designation that was come up with maybe 5 years ago. There are some in town here, and I'm not one of them, so I can't speak much to exactly what they do. Roofing consultant, irrigation consultant, general contractor, and all the suppliers, the grower, the plant grower. And then it's kind of my feeling that an architect is, since we're sort of tasked with bringing together a lot of different disciplines, they're sort of well suited for doing the same on a green roof, getting the waterproofing layer really bomb-proof and coordinating. I mean, a lot of what an architect does is just coordinate and make sure the right people are getting together and talking at the right time, which you really need to do. So you want to meet early and you want to meet regularly through the design and planning process. There are a lot of things that might come up that might tweak things that you decide to do. You might find that, hey, well, I think we want to go a little bit deeper with this system. Maybe we want to go 9 inches, 8 to 9 inches or something, instead of like a 4 to 5 inch roof. Draw from local providers where possible. That's my value judgment. Roofers with familiarity and experience with green roofs are preferable, definitely on the roofing side. There are a few in town that we know they're not scared. They can deal with it. So this proprietary system versus assembled components, there's pros and cons to each one. One is a full package. You might need that. One is more of a DIY approach where you're bringing all these components together yourself. A little harder. How is local expertise figured in and into either one of those? Again, I'm sure there's, with an American Hydrotech example, I'm just picking them. I'm just picking them. I'm sure that there are, I don't know how it works, I haven't worked with them, but they probably have some meetings where you sit down and you kind of like understand what some of the variables are that you could tweak and make some selections and with their input. How are regional materials included? Local materials. The Wildflower Center has, I believe, has used crushed brick in some of their more structural, as a structural component, rather than lava rock, which comes from more or less New Mexico, I think is the closest place you can get it. That's where we got ours. Maybe there's another supply that's closer at this point. Shale, expanded shale is another one. I think that can come from the northern Texas area. Access to knowledge. This is kind of another allusion to proprietary systems where you're not always told, you're not allowed to know what's in their growing media. It's a patented thing. It's kind of secret, which is weird to me. But so you want to know the nuts and bolts of the system components, just from more of a point of view of over time, understanding if something's not working quite right or you want to dial something up and something down, you know what you have to work with from the start so that you can kind of do something in a more informed way to what you got up there. You want some flexibility to change things even during design, and definitely kind of maybe change your mind a little bit about what you want to plant up there, maybe within the first year or something. Experimentation with plant species over time, and cost and warranties. When you get the full package, you get the warranty. That's another big plus, and you pay for it. So that is the Ballard roof. It's beautiful. I think it's American Hydrotech. Ballard Library, in Seattle. It's a really nice building. And then below is our own roof that we did, 2008 to 9, in East Austin. Monolithic versus modular. I have a kind of a preferred leaning on this as well, which is monolithic. The monolithic is like a blanket. It's a continuous thing, and it shares moisture and microbes and fungi and nutrients and root space. It's a whole system that's can share that as opposed to being separated off of component systems. But you have to get all the growing media up there, and then you get the plants up there, versus a system like Live Roof that has more of a modular system of trays. In this case, Live Roof has, you see the white there, you can pull those out, and I think they're trying to split the difference a little. They're trying to kind of make it a tray, but not with walls that go all the way up. They're trying to remove part of the walls to share, to begin to migrate some of that growing media and plant material across that boundary of the plastic wall. And the understanding with these is that you can, if there's a leak or a problem or you want to change something, you can go right to it if you've got a leak detection system and take out that tray and remove it. I think in practice, it's actually kind of hard to do that. But I, again, don't have too much experience with this. It's just what I've been hearing. Yes. Right. So that lower picture is probably in the Live Roof warehouse or nursery yard or whatever. Yeah, that's then another benefit to that is it comes pre-established. Yeah.
How many green roofs are there
in downtown Austin? Not many. Under 5. You're sitting in one of them. There's the Austonian has a deck. It's an amenity deck with a pool that uses HVAC condensate. I don't know. Some of the green roof activity in Austin in terms of identifying and keeping track of these things has kind of fallen off recently in terms of keeping up with what's being built. I have a feeling like I don't know, what time do we have here? I don't know where I am right now, how much I'm talking or not talking.
Time.
Okay, all right.
I'm sorry.
That's okay, no problem. You had the 20-minute and the 5-minute, so.
It's only 10:15, so you still have another half an hour.
Okay. Lots of time for questions. So some of these other architectural and ancillary conditions are things to think about. Your roof slope, you definitely want to get that to be a well-draining roof. So even with a flat roof situation, which is never perfectly flat, 1/4 inch per foot is kind of the understood flat roof acceptable drainage slope. When I was in Seattle doing a roof, I was talking with some people up there who really thought that you should make it more than that. 1/4 inch is probably too much. In the specific case of the little residential green roof I did, there was a roof house that popped up, and some narrow areas where there's lapping of seams, and you can get a situation where if you don't have the install done right with a membrane, you can get little pockets where the water won't really drain. There'll be a thin little layer of it, and because of how it meets the parapet and overlaps and comes up against the roof house and things like that. So if you have, in this case it was a shed roof, we had more drainage, more slope to make sure that water got off. Vents and drains, like roof drains, other roof penetrations need a border. Usually good practice is to use a rock border, gravel border to kind of offset, say this is your vent. I don't know, there's just different, 12 inches, 18, 6 maybe even. You want to make sure that plants aren't planted right up to that so that they can start maybe getting interested in going down it or interacting with it too much. And then access to, I referred to this earlier, access to and over, think about how that happens. The most obvious kind of approach is to have a walkway around the perimeter of it, right at the edge. But then you might be looking at railings potentially, especially if it's a shed roof and not a parapet situation. And railings are going to have they're going to go either into the wall or you have to figure out how they're going to be affixed to the roof, and you don't want to ideally you don't want to penetrate the membrane with that. Deck furnishings, shelter, a trellis or something. HVAC equipment can be a large presence. They're heavy, noisy, cast shadows, require clearances. Lots of times in these commercial roofs, you'll see kind of a zone that has a lot of that kind of equipment, and the green roof tends to stay pretty far away from that. And an irrigation system, what is coming up to the rooftop needs to be considered. Are there pumps? Do you want a hose bib, even though there's an irrigation system? Some of those things can start to really kind of whittle down the area that you have left over for vegetation. These three things, the growing media and the vegetation and the moisture, are all really intricately related. So you need to think about how they will interact, consider it. You're not going to know everything going into it. You can ask, get the benefit of a lot of built examples out there and talk to people, but in the end, you're not exactly sure, given your environment, your location, exactly what's going to happen, but you can give it your best shot. It'll figure itself out. The roof will figure that out retroactively as it continues. So the baseline concern within this component of these three things is keeping the plants alive and healthy and flourishing. So that's kind of the bottom line thing that you're shooting for. So you work from there to, if you're going to grow tomatoes, that's not done very much, but if you are, you're looking at a much deeper system and a highly organic, heavier content soil. You're not looking at a very inorganic, shallow growing media, which can take sedum and other kinds of things, prickly pear. Those things I just mentioned, prickly pear, sedum, they're not going to have a lot of evapotranspiration, so they're not going to have as much of a cooling effect as some of those other kind of kinds of plants, non-succulent. And the idea of succession, are you okay with allowing the plant regime to evolve over time? and not have a very are you willing to a certain extent, let the plants and the environment duke it out up there? And in 3 years, you have something that looks different from the first year of planting. Weeds are inevitable, but in some cases, I wouldn't say this for all, they can be seen as a pioneer species in a low-maintenance roof. For example, we had in our roof, in our studio, there's one big corner. It's a corner, but it's a pretty big area that has this really wonderful weed, I guess. It's not anything I planted, but it looks like it's almost like a cross between a moss. It's very short and some other sort of leafy thing. Yeah. Yeah.
Can you tell us a little bit about a roof that has animals on it instead of perennials, if we've seen any, or pros and cons, things like that?
Sure. I've decided that I've finally made peace with this plant, whatever it is, because it's actually kind of pretty. If I just like squint and step back a minute, it's like, okay, all right, it's good. It's green, which is kind of hard to do sometimes when it's a real shallow system like we have. And the other thing about that is if it's a pioneer species, if you let it be and you're okay with time passing and you getting older and being okay with things that happen without you trying to control them, they can then make an environment that's a happier environment for something else to come up and something else, and then something else that might be the thing that you originally really wanted to see up there in the first place. So let's see. There's greater initial plant coverage minimizes the weed introduction. So if you, they call it closing the canopy, I guess, when you just get enough planting out there and your space, your intervals of spacing are small, then you're going to have a lot less potential for, not a lot of open areas for things to kind of come in, birds to bring in seed or whatever, and weeds to get established. Seeding yields effective coverage if it's tended. In other words, if it's kind of watered well and you've sown it correctly. Native American Seed Company is a great source for blue grandma and curly mesquite and all those lovely seeds, buffalo grass. I've already kind of covered that low-depth growing media. It's typically very structured and inorganic, very mineral content, perlite, lava rock, decomposed granite, sometimes a little shot inoculation of compost. And I haven't forgotten about you. It's coming later. Shallower slopes allow for longer lateral hydraulic movement. So after you've established that this is going to drain well enough, you don't want it to get super flat, although there are people experimenting with that, really flat, to keep everything up there and see what happens. If you have a much higher slope, water's going to move through that faster. If you have a shallower slope, the water's going to just take its time to percolate through. So that's just something to be aware of and see what can be, see what you might notice. You might even play with some different kinds of things, mounding and see how, or even different slopes on the roof to see how it performs. So, yeah, the deeper media more closely approximates at-grade conditions and can be more organic and hold water longer. So in both extensive and intensive, these sort of canopy plants, I have an image there on the left that shows, I would put some prickly pear up on our roof to I was interested in seeing what might grow in its shadow, in its protection, and see what kind of little microclimate might arise. I found that Mexican feathergrass really likes to reseed in its shadow, and some other things tend to cluster at the base. Surface variegation. What you're seeing on the top left is a rubble roof in England, and they just threw a bunch of rock up there and decided they weren't going to plant at all, and any plant species were going to be volunteer. They would just show up. There are even blue roofs out there that are just water on top of the roof. There's a lot going on. I think this brown roof, they call them, is interesting. It actually performs in some of the same ways as a green roof does. But I included here just to, I think there's some logs in there in that picture as well, just to introduce the idea of having some other elements up there that might also create little mini habitats or conditions. The thing that I've been the most excited about observing over the last I guess 5 years, 6 years or so on our roof are a couple of folks in town here were doing. They created prairie design. They're kind of doing other things right now, so they're not doing a lot with that. But coming out of grad school, they thought, what if we take what they call them mulching tiles, these hexagonal tiles that have little like connector. They're about this thin, about this big, and connect them with gaps about this big, about an inch, inch and a half, and simulate the plateau of sort of rocky plateau where things tend to grow even in rocky areas. So we decided to try some on our roof, and they've just been spectacular, I think. Lots of stuff, like here's the Mexican feathergrass again, likes to find its way in these little pockets between the mulching tiles. The mulching tiles do a couple things. They kind of protect the soil underneath so that while something can't grow on the tile itself, there's a lot going on underneath it. And then in the gaps between the tiles, you can get some interesting plant seeds catch in there, and it traps moisture, and there's some interesting little mini conditions that happen. All of this for enhanced habitat and hydrologic character, meaning a lot of different kinds of moisture content in different areas, and biological activity. So installation is kind of a exciting day. This is another project we've been working on, and it's not completed construction yet. It's out at Mueller. It's their second amenity center, and it's north and east of the flight tower, John Gaines Park, and we're lucky enough to keep the green roof component in the design. It was on a big hiatus for a little while, this project, about 5 years. Came back up, and it's now it's over the hump construction. And the Wildflower Center also collaborated with this one, and we all decided on a more of a succulent palette. So there are going to be some grasses and some herbaceous seedings of mountain pink and bluebonnet, and they'll be interspersed with what you see on the bottom left there. And it's really exciting. It looks fantastic. They probably spent a good bit of money on the plant material because there's a lot. It's planted pretty tight, and there's a lot of them, and they're pretty well established. So this is primarily for non-proprietary systems, obviously, because that's all kind of taken care of with a proprietary system for the most part. The coordination should begin during the design, so you have key and secondary parties. Really, you kind of need to know, it's not too soon to get input from even the roofer or waterproofing consultant specialist. And you want to align schedules of these two components. You want to make sure that you plant not in the dead of July. So you want to make sure that the roof is complete, the membrane is complete to put the green roof material on there in the right timing sequence. And then the grow, you need to kind of have figured out, it can't just keep on going on and on, because if you're working and contracting with a grower, they kind of need to know when to have all their stock. If you're going for some sort of like 1 gallon plants or bigger material, they need to know when to have all their plants ready to go and grown. So pre-con meetings are real important, we've found, because these are meetings that happen right before you begin construction. There's a lot of surprises that you don't want to have happen like when everything's going up. You really want to have everybody meet each other, see each other, kind of get the game plan for how everything's going to be delivered onto the site and then taken up to the roof. All those kinds of things sometimes there's a lot of steps because green roofs aren't done a whole lot that people aren't aware of that need to be thought about. So is all that mapped out, staging all the materials and lifting them? You can go all the way from the 5-gallon bucket, like hand it to the next person up, or a big bucket lift, or there's a lot of different ways you can, well, not a lot probably, but you need to figure out how you're going to do that. Fight gravity. Allow time for all inspections. You really need to make sure, again, that membrane is, if it's a heat welded, they're welded seams, you need to make sure those welds are really not going to fail. And one of the reasons why the Wildflower Center prefers an elastomeric membrane, a seamless membrane, is because they think that the roots may try to find the seams and begin to kind of pry at them a little bit, especially if there's a little bit of an opening. What we do is go ahead, we use a TPO membrane, and inspector comes out, makes sure all the welds are well done and repaired and patched if they need to be, and then we put another layer of TPO over that. It's kind of a slip sheet. Leak detection testing, or simply flooding, is what some roofers will do anyway, just to see what's happening and if there's any leaking that's happening. And most roof warranties, you'll get a warranty, but they will not cover. You'll sign an overburden waiver, where you're responsible. You, the owner, is responsible for getting that stuff off in order to get to the leak. Maintenance. So I think the general thing to accept here is that because it's a living system, this idea of low maintenance and high maintenance you should put a lot of thought into that, because if it's going to be something like a landscape, you get out of it as much as you put into it. So when we designed our studio green roof, we decided we wanted to just kind of err way over on the low maintenance side, just put something up there and that was thought out and was going to be performing in a certain way, and then not really have to water it, not really have to think about the plants and doing much with the plants. That was that type of roof. Whatever it is that you do, I think there's a certain amount of acceptance that there's going to be a little bit of maintenance, and there's nothing like a no maintenance roof if you expect to not have problems. So then access becomes an issue, and who's going to do that maintenance? So what's your desired, it goes back to what you wanted to do in the first place. What's your aesthetic? And how much do you want it to perform? If these are, typically succulents are kind of like you sort of plant them and you can ignore them and they'll just do what they do. Although you have to prune them and chop them like I'm doing there, because they get really, really heavy and they grow huge. And prickly pear is actually very, very heavy. So the the maintenance regime may include all of those things that you're seeing there, or not. We don't fertilize. We have reseeded, done a little bit of replanting just to see what might work nicely up there. Mycorrhizal inoculating, I read a little bit about that, is a fungal community in the soil, and people are experimenting with inoculating with these kinds of products to see how it charges the green roof. Generally, the extensive roof systems are permeable enough and draining that they don't hold on to both moisture or fertilizer, so they tend to leach. So it's not a good idea to sort of like put a lot of stuff up there and to get a result that's really green and aesthetic, and then not have a lot of nutrients wash out of it. And that's a water quality issue, which is maybe taken care of if you've got all that water that's coming off the roof going into a landscaped area that's really going to be kind of like a rain garden or something that can absorb those nutrients. But that's one of the things that has been a concern in the past is, well, what's the water quality coming off these green roofs if there's a lot of fertilizer up there? There's different kinds of roofs that don't, that have different amounts of that kind of thing going on, or none fertilizing. And who does the maintenance over time? It may migrate. It may change over time. There may be the first couple of years, the sort of exciting period of that changes hands, or there's somebody who's not as familiar with the system who would be the person to take over doing some of that maintenance. That's something to think about. So it's a good practice to provide a maintenance manual, and the Wildflower Center has done that for us for the pool project, the Modular, John Gaines Park, and they've included a species list of that's kind of ours. The ones that we have are a subset of, so it's a kind of a little bit more extensive plant list. And then they've also included an irrigation schedule and different kinds of other maintenance concerns. And it's a laminated thing, and it's nice and neat, and it's meant to stand up over time. And it's a good idea also to keep a log to record what you did when, just so that you know. And then monitoring is another thing that can happen, where you're monitoring. You might partner with UT or watershed protection to measure runoff and so that more data can be generated. Yeah.
Maintenance in particular, you've got to be careful with your species because a lot of them can generate so much debris. You've got to take
Yeah.
into consideration all the leaves and everything that you've got to get down off.
Mm-hmm.
I mean, small projects, like your project, you can do great. Keep your garden debris.
Depending on what you plant, yeah. I mean, we've got, if you let things brown, and there's a little bit of a mulching attribute that comes with that if you let things brown and just stay up there. But then sometimes at a point it'll hamper new growth, so you want to cut it back. And yeah, it's, in my mind, it's something that you would do at grade on the ground with another landscape system.
Those are species that you might not want on the ground because they are invasive.
Mm-hmm.
It might be really tough if you plant them on the roof because they're very durable. But you can have the same issue like Japanese grasses.
Yeah.
Excess spreading of seeds.
Right. And some of those things have tap roots that are kind of the long ones, and they hopefully will be discouraged by the green roof situation where they just can't keep going down because there's only so much depth. Another thing is that I found is like leaves from trees that drop onto the green roof. That's something that, I'll go through with the sedum, and I'll just kind of comb it out and deadhead some of the sedum flowers, and at the same time get a lot of the post oak leaves that are all over the place. Yeah, maintenance. And be open to succession and migration of species over time. That's a whole huge conversation. So this last bit, getting towards the end here, another, to me, really exciting couple of components that we were able to include in the pool project at John Gaines Park are a solar trellis that has some vine plantings on it. It's not, as well as the green roof, it's sort of separate and in a different location. You see it coming through the breezeway there and coming out and bending around to where the pools are, rainwater collection. And you can see a little bit of a bluish color in that cistern, perhaps. We've got two bathhouses, and each one has a wall that we expanded to become a water wall. So it's about 2 to 3 feet wide and 16 feet long, and it holds a bladder, and it's going to take all the water discharged from those shed metal roofs that you see, and it dumps into the rainwater cistern water wall, and that water is used to irrigate the green roof. Will be in a matter of months, I hope. And also some vine plantings on the ground, and so it's kind of a nice, happy little educational kind of display there of different components of this system, of this architectural system that is working to keep some green infrastructural elements going. The other thing that is not been explored here in Austin, which I hope will, is something they've been doing in Germany for a little while, which is to look at the symbiotic relationship between solar panels and green roofs, in which the green roofs cool the panels, and the panels help to shield the sort of first blow of the sun. There are a lot of panels, I don't know if people are aware of these, that let a certain amount of sunlight in, so it's not a full shadow over the plants. The image on the bottom left there is an interesting one that I found at Duke University, where they're actually not putting the solar panels right kind of at level, roof level, with the green roof, as they are on the right-hand side there in project in Germany. They're raising them up to make sort of a habitable area and have a little bit of a cooler environment to see how those plants might respond to that. Obviously, the conditions here are really harsh in Austin, and rooftops just get a full blow from sun and wind, UV. So you want to think about the water path and avoid discharge into the storm sewer, collect rainwater, figure out how it's distributed, and any runoff that does happen off the roof, you funnel into at-grade landscaping or a rain garden. We're doing a rain garden as well at the pool project, or possibly a water feature, or it goes right back into the rainwater tank, which is what happens at our studio. There are also some projects that kind of celebrate all these different components. So the gutter is a little wider, and it's kind of made out of a special material, and it's custom. Or the scuppers have some cut steel plate salmon jumping down, or things like that. The rainwater system is part of a closed-loop irrigation system. I mentioned that. And we also collect our HVAC condensate, and we decided not to have a separate cistern or collection tank for that. We just commingled it with the rainwater tank. It just seemed simpler for the time being. So I talked about the PV array and that synergy that happens between the plants and the solar panels. I'm really hoping, it seems like Austin would be a prime candidate for experimenting and doing some trials with solar panels over green roofs. The things to be aware of there, the sort of underside of all that, the kind of difficult nuts and bolts part is how is that armature fixed to the roof, thinking about all of that. So that's something to contend with, because there's more stuff on the roof that potentially has some bearing on the roof. Some local resources are, as mentioned, the Green Roof Advisory Group. They came up with a 5-year implementation plan, and I think we passed by the 5th year already. It's my hope that we'll have a little bit of a resurgent interest in seeing if there's a GRAG point 2 that follows up on some of the work that they were doing then. And both of the documents that were produced out of that work are listed there, the web links. That can be, including the one, the left there is the first one. Pretty long, goes into a fair amount of detail on everything that was done and the incentives that exist in other parts of the country and what we can learn and what we might be able to look forward to in the future implementing. The Lady Bird Johnson Wildflower Center, the Ecosystem Design Group, has done a lot of work here. They've ramped up quite a bit in the time that I've been here. Back in Austin since 2005, it seems like a lot that has been growing. What you're seeing in the top 2 pictures are a whole series. I don't know how many people have been out there. It's been there for a little while now, since 2006 or so. Maybe 20 of these, like 5x6 white pedestal parapet roof trials, where they're trying out a conventional roof and a cool roof, which is sort of white, reflective, and a green roof to see what kinds of temperatures exist on the surface and in the soil. They have thermocouplers in the soil, and then water runoff. And they're now affiliated with UT, so there's their kind of capacity is deepened over the years with that. And they also have a few projects on campus. One of them is that ticket kiosk at the front, and then they have another one. And they're also working hard on a trademarking, I believe, something called Sky Turf. They already have been doing interesting experiments with a turf mix with native turf, like buffalo grass and blue grama and curly mesquite, and there's another one I'm forgetting. And now they're looking at the growing media itself, having trademarking that. Finally, Growers is an organization that I helped co-found years ago. We're not really active right now, but in the past we've had little 7x7 presentations where we've had some different projects around town come and just give a little short slideshow, and the next one comes up, kind of like a Pechacucha style thing, so that people could kind of mingle, and there was a keg, and it's just fun, and people just kind of learn more about green roofs. That's not happening so much anymore, but we got our nonprofit status, so hopefully we can kind of eventually make that ramp back up again. Yes?
If I have, say, a pitched roof at, like 30, 45 degree angle, am I totally out of luck in that situation, or is there some type of terracing?
Yeah.
Or everything I see in the picture is all flat, so I'm just kind of curious if you were talking
Right.
about what you can do with a pitched roof.
You can, and you can do them. I'm going back to that on the bottom. 1 minute. I'm going to do a lot in 1 minute, including get to Paige's question. You can do it. You just have to terrace it and pocket it. Yeah, and there's systems that do that. And again, I don't think there's much done. It wasn't credited on their website, the Berm House, which is on the Lower East Side of Austin. And Wildflower Center did also have a big part in that. And you can see the erosion, I don't know what those things are called, but they hold the soil. So yeah, that you should look into that. And yeah, I mean, I think that you just need a deeper strata of soil and organic mix to grow annuals, and you have the same kind of like heavy input scenario that you would have with a garden where you really have to fertilize quite a bit and add compost and everything. But it's absolutely possible. It's just a matter of weight and access. I don't know if that really totally answered your question, but yeah. So I guess I'm done. Right on time. Thanks, everyone.
I hate being the bad guy, but I am a stickler about keeping things on time. So I just wanted to mention the last day of training, we're actually going to be at the Wildflower Center, and I'm still working out the complete agenda, but most of the afternoon is going to be tours. So we're going down the cave. Maybe we'll go look at the green roofs. So look forward to that. And we are going to take a 15-minute break, and then we'll be back in here, actually for Jonathan Gardner from the Wildflower Center. So that's a nice segue. So be back in 15 minutes.